So therefore, these are the two characteristics we need to define the line, and we've got them here. So now we just need to piece it all together. We need to piece it all together. Okay, so here's how we do it. I'm going to give you the equation of a line. I'm going to give you the equation of this line at least, and I'm going to show you why it has to be true. So the equation of a line always links together the x-coordinates with the y-coordinates. In other words, you give me an x-coordinate, and I'll tell you what the corresponding y-coordinate is going to be. Okay? So the equation of line 1, so let me write it here. So the equation of line 1 is going to be y equals 1 times x take away 1. Okay? 1 times x take away 1. So let's have a look at this. Let's have a look at this. The best way to see this is using a table of values. So what I'm going to do is I'm going to draw a table of values out. So along the top row of my table, I'm going to have all my x values. Bottom row of my table, I'm going to have my y values. I'm going to start my x values at 0, and I'm going to go up to 4. So 1, 2, 3, and 4. Okay. Now, if x equals 0, just using this equation, what's y got to be equal to? So literally just stick 0 into this equation.
4, 5.
Well, if I stick 0 into this equation, so y equals 1 times x take away 1, in this case 0 is equal to x.
Yeah, so 1 plus 0 minus 1.
Good, so what's 1 times 0?
0.
Take away 1?
0.
0 take away 1?
Negative 1.
Good, negative 1. That's what y is going to be equal to. Okay. Now, that should make sense because that should be our y-intercept, shouldn't it? Because you said when x equals 0, that's when we get our y-intercept. So that point there should be our y-intercept. Now have a look in this equation. Where is that negative 1?
At the last.
Yeah, this last thing here. So this last thing here is our y-intercept. Why is it our y-intercept?
Because it starts.
It's the end thing, it's the constant, isn't it? And because you've said to me the y-intercept is when x equals 0, it's literally the line where all the x-coordinates are equal to 0, that's our y-axis, okay? Well, if I stick 0 into this thing, anything with an x in will just disappear. Any term with an x in will disappear, because it's 0, okay? Anything times 0 is 0. So that term disappears, which means you'll just be left with y is negative 1. So it's always the case that that last number here is always our y-intercept. Whenever you see an equation of a line written down like in this form, it's always our y-intercept, okay? Let's keep going though. So what happens if I stick x equals 1 into this line here? What do I get?
1.
1 take away 1. So if I stick x equals 1 in here, maybe if I get rid of that. 1 times 1 is
1.
take away 1.
Sure.
Good. So in other words, the next point is 1, 0, and you can see that on the line there. That's 1, 0. Makes sense? All right, what happens if I stick 2 into this equation?
1.
Yeah, absolutely. What happens if I stick 3 into this equation?
2.
2. And what happens if I stick 4 into this equation?
3.
3, good. So watch what's happening every time I increase an x value. So every single time I move to the right by 1, I increase by 1. Well, are you happy that whatever I'm increasing up or down by is given by this number here, the number being multiplied by the x? Yeah? Because obviously, if I'm increasing by 1, I'm increasing the x every single time, then I'll be multiplying by whatever number goes out the front there anyway. So therefore, that will tell me what I have to increase by. So in other words, this 1 here, the thing in front of the x, is equal to our gradient. Does that make sense? Yeah? Because of course my x is increasing by 1 every time, and it's going to be multiplied by whatever my gradient is in the y-axis, in the y direction. Okay? So therefore, the thing which I'm increasing by is obviously our m. So what I can say finally then is that the general form of an equation of a straight line, okay, is given in the form y equals mx plus c. Okay, so y equals mx plus c, where the m is the gradient and the C is our y-intercept. Okay? Now this is the only actual form that we're going to look at for the moment. Okay? We will look at general form a little bit later. But for the moment, I just want you to get your head around this thing here. This is a really important form. It's a slope-intercept form of the straight line. Okay? So using that then, given that I know that let's look at line 2 now. Given that I know the gradient is equal to a half, and the y-intercept is equal to 1.5, could you tell me what the equation of line 2 is?
Half.
Good. So give it to me as y equals. So y equals.
Y equals half.
Yeah.
Multiplied by x.
Good. So that's 1.5 there.
Plus.
Good. Why is it plus and not minus 1.5? Is that thing positive or negative?
Positive.
It's positive, so therefore you had to put positive in front of it. Yeah? Whereas this thing up here was negative, hence we put a negative in front of it. Okay? So it's always y equals mx plus the c, okay? And obviously the sign of the c, the sign of the y-intercept is always given before it. Okay? So that's it. Okay, if I ask you now, if I give you 2 points, and if I ask you to find the equation of the line passing through those 2 points, are you happy you can do that really easily? Just calculate the gradient, we've done that. Calculate the y-intercept, okay? And then the rest is easy. The rest is easy, okay? So let's actually go through an example question together doing that. Is that okay? So I'm going to give you 2 points, and I'm going to ask you to find the equation passing through these 2 points. So find the equation of the line passing through, let's say the first point is going to be 1, 7, and the second point is going to be 3, 5. Okay? So that is through. Let me write it out properly rather than the abbreviated version. Okay. So let's go through this together and see how we get on. So, are you happy that the 2 things that we need are the y-intercept and the gradient, and then we can just stick it into this form? Okay? Well, looking at this, I think the first thing we can do is actually find the gradient. We were doing that over there. You happy? So can I ask you to find the gradient? Very quickly, can I ask you to find the gradient of these 2 points? -1? Yeah, fantastic, okay. So yeah, just simply 5 take away 7 divided by 3 take away 1. Good, excellent. That's the gradient. What else do we need if we were going to find the equation?
Y.
The y-intercept, good. Now, we could absolutely think, well, okay, if a is equal to 1, 7, then we can just think, well, okay, if that's the gradient, visualise it on our graph, it means if we move across by 1, we move 1 down, then we can kind of move backwards until we get to the y-axis, in other words, a 0 something. I'm going to show you an alternative method, however, because this is fine if you've got a point which is close to the y-axis, but if you haven't, if you've got a point which is like way out here, it's like 100 something or other, okay, then you're going to have to go back 100 times until you get to the point which you're after. So a quicker method is to think, well, look, I know that is the form that I am after. I'm after y equals the gradient times x plus the y-intercept. So I'm going to start there, okay? I'm going to say, okay, using y equals mx plus c. Do we know anything about this line? Do we know y, m, x, or c?
Y equals m.
Good. So what's the m?
Mx minus 1.
It's -1. So stick that into the equation. Okay. So if we go, well, okay, if we use this, y and x are just general points that lie on the line. The m is equal to -1. So we're going to have -1 times x. We don't know the c though. Does that make sense? So I'm just filling in the pieces that we know. Okay. Well, have a think. Because y and x is just a way of linking all the x and y coordinates together on a line, do we know a pair of x and y coordinates that lie on the line? Yeah. What?
The y is 7 minus, no, 5 minus 3.
Okay, that's how to calculate the gradient. But all this means is a way of connecting together a pair of x and y coordinates that lie on the line. Okay? Do we know a pair of x and y coordinates?
The pairs is the question.
Exactly. These are the pairs which we've been given. So we've actually been given 2 pairs that we could possibly use. So which one do you want? That pair or that pair? A or B?
B.
B. Alright then, it doesn't really matter, but let's go for B. Okay, so now what I'm going to do is stick in my x and y value into this line. I need a pair of x and y coordinates. That's a pair of x and y coordinates. So stick it into this general form, and let's try and see if we can find what C is. Okay? So I'm going to say using this point here. So using, well, if this point here tells me that x equals 3 and y is equal to 5. So if I use that in here, would you be happy I just need to stick x equals 3 and y equals 5 in this equation? So I get 5 is equal to, well, negative 3 plus c. Okay?
Is it 8?
Good, fantastic. So I just need to solve that now. So add 3 to both sides, and I find my y-intercept there. Does that make sense? Okay, so you found your gradient first. That's easy. Okay, if you're given 2 points, it's easy to find your gradient. And then you just solve an equation using a pair of x and y coordinates that you know lie on the line, and you'll be able to find your y-intercept. So therefore, what is the final equation of this line?
Y equals negative 1x plus 8.
Excellent, well done. So always remember, once you found your x and once you find your y-intercept and your gradient, always definitely remember to actually give the final answer.